Good evening, everyone. My name is Patricia Sayano. I'm currently an engineer at Samsung Research Philippines, and um, I work as a developer on some of the 5G O-RAN solutions that Samsung offers. So, so today I'll be talking about the open road to 5G. So this is just a short overview of what we'll be discussing today. So first, we'll have a short background for some of the concepts of what the RAN is and Open RAN. And then we'll discuss what Open and Open RAN is as well. And then how Open RAN can be applicable to our current 4G solutions, innovations and mass adoption with Open RAN. And then finally, I'll discuss a bit on Samsung's vRAN solution. So we'll go ahead with the background for now. So first, we'll go over what a VRAN is, as we'll be talking about this a lot in this session. So just a quick idea of what the RAN or radio access network is. So this is the network that connects individual devices, so like our phones and our computers and stuff like that, to other parts of a network through a radio link. So we have three components for this one. We have the core, so in a regular legacy RAN, so we have the core, the BBU or the baseband unit, and then the RH or the remote radio heads. So the core is in charge of running complex functionalities that would allow us to have the 5G features, so like the speed and all of for the bandwidth and stuff like that. And then the radio units are what we connect to as end users. And these are the ones that are found in the cell sites. So the core could be usually remote. So that would depend on the operator where it would be. And then in legacy RAN networks, between these two components, we have the baseband unit or the BBU. So usually this is also within the cell site. So the BBU is the one that that is the one that sends the data to and from the site's radio units or the RU and the car network. So yeah, VRAN stands for Virtual Radio Access Network. So as technology continues to improve, one of the developments with the RAN is we are able to virtualize it. So this means that the hardware specific components become software based that are run on servers. So instead of like having dedicated hardware specifically for the BBU, you could just turn it into a software that would run all of its functionalities. So this creates what we call the VRAN or Virtual Radio Access Network. So here we can see on the diagram, on the left, the legacy RAN, and on the right, the VRAN. So just by looking at it, we can see one of the main differences is that the BBU is split into the into two components here. So yeah, so these two components are the virtualized distributed unit or the VDU and the virtualized centralized unit or the VCU. So the VDU can be found usually near the radio unit, and this one supports real-time processing. So this includes communication between the user and the cell site. So on the other hand, the VCU can be placed either on the cell site along with the VDUs and radio units, or it could also be placed remotely. And also this is in charge of handling the VDUs. So this improves reliability and simplifies the network architecture. And also like we can see here, the VCU can be in charge of several VDUs as well. So in addition to the VDU and VCU, the other components of the Open RAN is the RAN Intelligent Controller or RIC. So here on the right, we see the overall Open RAN architecture. So this RIC is introduced to provide intelligent radio resource management. And this also provides optimization for various components within the RAN. Additionally, this is where you could deploy AI ML models to help with resource management or other needs. So this could be like in helping decide what type of policies you should have. So like um, what type of metrics you should focus on to deliver the best performance. So this is what the RIC can help out with. So in the middle of each of these boxes or the components, we can see the interfaces. So these are the A1, E2, F1, and the open front hall. So in order for the different components to be able to communicate to each other, there has to be some sort of protocols or specifications in place. So this could be in the format of the messages that you send in between the components or the sequence of events for a certain process. So like if you want to have like certain like let's say a subscription to happen between these two, so you would need a proper sequence for that as well. It could also be in the form of what kind of information will be allowed to flow between two components. So like maybe you don't want all of the data that you get from your users to pass through the OCU. You want it to go straight to the RIC. So these interfaces could also help out with that. So yeah, so now that we know more about what the RAN is, so we'll now talk about what the Open RAN is. So one of the advantages of having the vRAN is that operators can have better resource management and scalability over their networks. So these solutions are typically developed by different companies, or as we'll call them, vendors in this discussion. So these vendors would create solutions for vRAN and offer them to different network operators. But one of the tendencies with this is that there would be a vendor lock-in. So this means that instead of buying just the software solution, the network operators would also have to buy the hardware and other software as well of the same vendor. So this is because sometimes components make use of proprietary purpose-built hardware. So this could be also in the form of the interfaces that we saw earlier between the RAN and the hardware, or between other components within the network. So that would mean that the hardware and the vRAN from different vendors would be incompatible. So like, for example, like the format of the messages would be different. So you can't really mix and match the components and the software and stuff like that. So currently as well, 60 to 65% of the total cost of ownership over a network. So if you want to have your own network, that most of your cost will lie on the RAN or the radio access network. So here I'll just show you like what a proprietary vRAN would look like. So in a proprietary vRAN, the radio unit would be created by the vendor, and the BBU functionality would be made using proprietary software. So additionally, this means that the interfaces or connections between the components would also remain proprietary. So you can't really mix it with another one, since the vendor would have complete control over what the interface is and how they communicate. And then we also have a CRAN. So CRAN is another similar thing compared to vRAN. So except that the difference is that in a CRAN, this focuses on centralized management of units. So CRAN stands for centralized cloud radio access network. So here in the diagram, we can see that you have a BBU pool. So you have several BBUs together. And then this can be used by different radio units. So for example, rather than having a fixed BBU for a radio unit, like what we saw earlier in the vRAN diagram, you could have a set of radio units that could connect to anyone in the pool. So this would allow the BBUs as well to have a more distributed load in a sense, since the radio units could be assigned to a different BBU depending on the traffic. So this shared processing across multiple base stations enables cost savings on baseband resources. It also enables energy efficient network operations and just enhances overall network performance. So one of the things about this though is that the CRAN software used for these BBUs can be proprietary, just like the VRAN. So it's also susceptible to vendor lock-in. So here we see some of the challenges with VRAN and CRAN adoption. So while VRAN has several benefits, there are still some scalability issues that it has. And it also requires you to have dark fiber for the front haul of the network. So this is the connection between the radio unit and the VDU. So also this dark fiber can also be relatively hard to acquire. So in addition, both VRAN and CRAN have a limited number of alternatives for some interfaces, such as the CPRI or Common Public Radio Interfaces. So this is also a interface between the VBU and the radio units. So as a result of this, establishing open interfaces was identified as a critical requirement by carriers in order to maximize the benefits of virtualization and cloud deployment. So for this to happen, carriers contend that there needs to be more competition in the RAN market, since currently there isn't that much out there yet, since the vendor lock-in is still quite prevalent. So the goal of Open RAN is to eliminate this vendor lock-in situation by having open standard interfaces that would allow operators to build a best-of-breed multi-vendor network. So yeah, now we'll move on to how Open RAN can be applied to current 4G networks that we still make use of today. So currently, network operators are still investing in the 4G network infrastructure. So some of these include increasing the 4G LTE capacity for heavy usage areas and enhancing coverage of their networks. So this includes indoor coverage and low traffic areas such as rural or remote locations. So the carrier's critical needs as of now include new efficiencies in 4G LTE, since it's still what is mostly being used today, and then also advancing inter-carrier interoperability. So this is being able to operate with different carriers, and also preparing for 5G as we shift to 5G technology. So Open RAN also provides an opportunity for these businesses to rewire their business case and deploy more cost-effective networks. So here we have some of the major differences between 4G and 5G. So as we can see, the peak download speeds are theoretically to increase up to 20 Gbps, which is over 100 times more than the current theoretical peak download speed of 150 Mbps in 4G. In addition, a far lower average latency is expected, from 50 milliseconds in 4G to less than 10 milliseconds in 5G. So this is what would also allow us to have more automation use cases. So like in self-driving cars that they often mention. So since these things would require quick responses, especially from whatever they're processing. So 5G would be able to help with that. So 5G will also offer a much higher average speed for end users. So from an average of 10 to 50 Mbps in 4G, so it will be around 100 Mbps in urban areas. So this is the download speed that we would usually experience. So the biggest change that this will bring is the explosion of bandwidth required to handle the 5G network. So this would require network operators to have a higher base station density and higher data processing capabilities. Because of this would result as the front haul to become the biggest expense of the 5G network. So with the introduction of Open RAN systems, the front haul will be able to be split into functional units, and this would enable smaller capacity requirements compared to traditional CPRI links. These savings as well would be in addition to the substantial decrease in capital outlay that operators can achieve with a wider choice of vendors for key RAN elements if they could deploy more general purpose hardware in the RAN. So for instance, Dutch Telecom has stated that an open RAN architecture will likely reduce their 5G capex bill by about 50% less compared to 4G.6. So with the growth in automation, machine learning, AI, and other latency demanding applications, wireless networks will become increasingly complex. Network operations need to be autonomous and programmable, just like self-driving cars. So this brings us to another goal of the Open RAN, which is to bring intelligent software-defined networking and automation to wireless networks. So in order to achieve this, every element in the network needs to become modular, software controlled, programmable, and make use of standards-based open interfaces. So in an Open RAN economy, or if Open RAN was adopted by all operators, it would be a win for almost everyone. There would be healthier competition within the RAN market, as it would allow more people or vendors to enter the market. So instead of having to produce their own hardware and software together, so instead of like all of the components, they could focus on one aspect due to the standardization of interfaces. Operators could also partner with smaller network providers to increase their 5G coverage because of this open interface. So even though the smaller network providers would be making use of different hardware or different software, because of these open interfaces, there would be not much problems with the communication with a bigger network. So this would also lead to addressing the connectivity needs of enterprise customers in a more innovative manner. So here we have the critical factors for the success of Open RAN. In order to achieve the mass adoption of Open RAN, we need to have a strong industry partnership and ecosystem. A robust ecosystem is needed to encourage operators to have confidence in the viability of Open RAN. So it's unlikely that operators will go for an Open RAN product, whether it's in the radio unit or in the baseband, if they don't have enough options to consider, which is why having more choices in the RAN market is definitely something that needs to be done. Also, we have interoperability between multi-vendor products. So this is required to have a truly best-of-breed open network, but still remains one of the major concerns of network operators, which is why single vendor strategies are still prevalent. So in addition to this, operators would also be reluctant to have a multi-vendor system if they find it too difficult to integrate these products tightly into their network, or if they lack the proper skills to do so, which is why system integration is also a critical factor for the mass adoption of Open RAN. And then another major concern is the complexity that multi-vendor networks might bring in. So employees of the operator might be a bit resistant to this, being put on top of the existing complexities of network operations. So this is why employee concerns should also be addressed, and they should also be given proper training to be able to handle these new technologies. And then lastly, we have the collaboration between the vendors and operators um, as one of the keys to ensuring that Open RAN development is to succeed. All of this would be useless if one or the other would refuse to cooperate. So later we'll go over some of the efforts as well for Open RAN 5G among different companies. So this includes Samsung as well. So now that we know about Open RAN and how important it is as we move forward into 5G, now we'll go over Samsung, one of Samsung's 5G O-RAN solutions, which is their vRAN. So Samsung's part in promoting Open RAN for 5G can be seen with their vRAN solution as well, as this is an Open RAN compliant product. So Samsung's vRAN was also the first to deliver to the market the VDU and VCU that run on general purpose servers. So earlier we discussed what the vRAN is. So these VDU and VCU softwares can be run on common off-the-shelf or COTS servers. So these COTS servers consist of standard components, and these are readily available from various suppliers. So here on the right, we have again the overall Open RAN architecture. So, you know, with these, so the Open RAN also has a lot of documents on these, so that anyone can easily access them. So including the specifications for the different interfaces and components. So here we have the Open Front Haul interface. So for Samsung's VDU, they have the Open Front Haul interface as well. So this would allow operators to choose different radio units from different vendors. And this also means that multi-vendor DU-RU interoperability can be realized. And then also in this type of architecture, the RAN software from a certain vendor would be able to communicate to its own radio unit via either their own service interface or to another vendor's radio unit via the Open Haul interface. In addition, Samsung's vRAN is able to work with the RIC in order to optimize network resources and improve user service quality. So here as well, we have the timeline for Samsung's vRAN release. So they started in 2018 with the VCU, and then eventually moved on to have the VDU and massive MIMO support. So in 2020, the fully virtualized RAN had its commercial release in the US. And then starting earlier this year, Samsung has already deployed Open RAN compliant 5G vRAN solutions in commercial networks. And this offers seamless interoperability between Samsung's VDU and third-party massive MIMO radio units. So one of these releases was with Vodafone in Europe. So together with Samsung as the leading vendor, they are planning a wide-scale 5G commercial deployment based on an Open RAN architecture. So in January 2022, they were able to turn on UK's first 5G Open RAN site, which carried live customer traffic. And then in early 2023, they have plans to conduct a commercial pilot of 5G Open RAN at mobile sites across 2 rural areas in Germany. So this will be the first deployment of Open RAN technology in Germany that is fully compliant with the specifications and roadmap endorsed by the leading mobile operators in Europe. So in addition to these, Vodafone and Samsung also worked with Marvell to incorporate their system on a chip technology into the latest standard COTS server. So combined with Samsung's vRAN, it speeds up the data processing required for complex radio network functions. This would enable the Open RAN to deliver features, security, and performance that is on par with traditional mobile radio networks, as well as improve the energy efficiency of these mobile sites. So this is just one example of how multi-vendor networks are possible in a commercial setting with Open RAN architecture. And it's also not just limited to the radio units or the software. So it could even be with the um, servers that they would use to run the VDU and VCU. And then another one is in Japan with KDDI. So together with Samsung's vRAN, they were able to successfully complete the world's first 5G standalone Open RAN site that is powered by vRAN. So KDDI made use of different Open RAN compliant solutions, such as Samsung's 5G VDU and VCU, and also made use of Fujitsu's massive MIMO radio unit. So here on the right, we see the diagram of how the Open RAN differs from the traditional RAN. So the dedicated hardware is replaced with the COTS server, which runs the DU and CU. And then the server would communicate with the radio units with making use of the Open RAN specifications for the interface. And then finally, we have Dish Wireless. They are currently building the first nationwide virtualized Open RAN compliant, compatible 5G broadband network in the US. So they chose Samsung to supply the vRAN and RAN solutions, as well as a variety of Open RAN compliant radio units, including the massive MIMO radios. So yeah, that's the end of my presentation. I hope it was informative and helpful for you to learn more about Open RAN and 5G. So thank you, and like if you have any questions, just feel free to ask.